So my name's Max Schulocker. I'm an assistant professor here at MIT in the Department of Electrical Engineering and Computer Science. And I lead the Novel Electronic Systems group, where we try and reimagine and most importantly, physically build and create what we think future electronic systems might look like one day. So my interest in nanotechnology first began during my own PhD, when I had the opportunity to work in a nanofabrication facility and actually build and test new types of devices using new materials. Being inside the lab, just dressing up in bunny suits, as we call them, was a really fun experience. And that's what kind of started it all. During my PhD, I focused on trying to build systems using new types of technologies, and specifically we focused on carbon nanotubes, which are just rolled up sheets of graphene to form nanocylinders with a diameter of only 1 or 2 nanometers. They're extremely, extremely small. And it's been projected that if we can actually build working systems using these new types of technologies, we can dramatically improve the performance and speed and energy efficiency of computing systems. The work that I used to work on myself was just proof of concept. Right? When we try and build new systems using these new technologies, there's so many problems, so many obstacles. And finally we got to the point where we could actually build working systems using these new materials, really for the first time. And now the work here at MIT is trying to go beyond proof of concept. We're trying to build an actual chip that can actually perform new types of applications. Historically, I think there's been a gap between the motivation that we use to motivate the research on new types of devices and technologies and what we actually show in the lab. And now my group here at MIT is trying to shrink that gap. We're trying to actually build the systems, actually do the applications that we use to motivate all this work on these new types of technologies. A very interesting question is to ask, what does it take to build novel electronic systems? And in order to build a novel electronic system, I think it doesn't suffice just to tweak the material you're using, or to change your device that you're using, or to make a small improvement to your circuit, or to try and modify your architecture in a little bit. Rather, I think if we want to dramatically improve the performance of electronic systems and enable new types of systems that we can only really imagine today, I think we really need to take a holistic approach towards building new types of electronic systems. And that involves using new types of materials to build new types of devices, to enable new types of systems and architectures, ultimately to enable new applications. So I like to say that it's not about finding the best device or the newest and fanciest architecture, but rather it's all about finding the right technology to build the right systems in order to enable the right applications. And when you can combine all of these together, that's when I think you can create something really special.